In this video, I will show you how to use a low voltage transformer, a metal bridge rectifier, and a DC to DC boost converter etc. to make a car battery charger. Step by step in details. This is a DIY made transformer by utilized, modified recycled microwave oven transformers. Its carrying power capacity is 450 watt by its core size. The AC 240 volt power has been connected to the transformer's primary, not switched on yet. A pair of multimeters probes have been hooked to the transformer's secondary, with meter's AC voltage position selected. Switch the AC power on. The multimeter has indicated the transformer's secondary, which is the output of 8.7 volt. Switching the power off now. That is a heatsink with a few parts assembled on. The square thing bolted there is a metal bridge rectifier. A capacitor with its values of 2200 mAh and 63 volt has been tied on the heatsink. The wires connected are showed from this simple diagram. Metal bridge rectifier is here. A capacitor is there. The white wire to the positive. The gray wire to the negative. This voltage and ampere meter, with 10 ampere capacity fixes into slot here. A 9 ampere break is here to protest against overcurrent. The button here will pop up when the DC current goes through over 9 amperes. A heatsink here was from a broken television of the old style. The DC converter here is a step up, or boost converter in other words. It has maximum DC 20 amperes and 1200 watt capacity. A black thing attached here and secured by the cable ties is a 12 volt cooling fan. Its interface are here. That fan came off from an old computer. These are the input terminals which can take the voltage between DC 8 volt and DC 60 volt. Those are the output terminals which its voltage is adjustable between DC 12 volt and DC 80 volt continuously. Input maximum 20 amperes fuse is here. That is input low voltage protection, which adjusted by the factory. This is the output current adjuster, which adjusted to maximum 20 amperes by myself. That is the output of voltage adjuster. It has been adjusted to near DC 15 volt. As I mentioned previously, the boost has maximum 1200 watt capacity. However, the actual output wattage depends on not only the input voltage figure but also the output voltage figure adjusted. Let me do some calculation and explanation. From AC to DC, which means AC goes through bridge rectifier then becomes DC. As we knew at beginning, AC was 8.7 volt times square root of 2 minus 2 times 0.7 volt. Equals 10.9 volt. So the maximum intaking wattage is 10.9 volt times maximum current 20 amperes equals 218 watt. The effectiveness of this boost converter is 95%. Then the output wattage will be 95% times 218 watt equals 207 watt. So the output maximum current by this wattage will be 207 watt equals I maximum times the voltage adjusted, say 15 volt. Then I maximum equals 207 watt over 15 volt equals 13.8 amperes. In fact, the voltage and ampere meter's maximum current capacity is 10 amperes. Also used a 9 ampere break to protest against more than 10 amperes current to go through the meter. The actual output equals the current is not 13.8 amperes, but is 9 amperes times the voltage of 15 volt equals 135 watt. This will be the charging capacity for the voltage adjusted at 15 volt. As we can see, the output of charging capacity depends on those of the facts. This is a switch which will be installed somewhere between the boost converter and voltage ampere meter in the circuit, plus DIY made wires. Finally, to secure all things on this board, put all components on the board like this layout, to drill holes on the board, then screwing them to secure. Finally, to use those wires to connect them, according to the diagram. Alright, all done. These are the screws on both sides on the board, which secured the components. Also, the wires have been connected. The circuit's connection diagram is here. The DIY made transformer is here. The metal bridge rectifier is bolted on the heatsink plate. The boost converter is secured on the board. The voltage and ampere meter is right over there. The switch which turns the output on and off is here. A 9 ampere break is screw on the heatsink plate. A pair of battery clamp cables are secured on the board. The wires and cables here look complicated. In fact, they aren't. The power socket of AC 240 volt is here. Twist purple wires connected to the AC 8.7 volt terminals from transformer and AC terminals from bridge rectifier. The wire which connected to negative terminals between bridge rectifier and boost converter's input is black in color, and positive is red in color. The twist wires, which connected between the boost converter's output positive and switch is red in color. Also, twist wires from the switch to 9 ampere break is pink in color. The voltage and ampere meter's thick black wire connected to the boost converter's output negative terminal. The meter's thin black wire is no need to connect anywhere, and just hanging along here. The meter's thick red wire connected to negative battery clamp cable. The meter's thin red, yellow wires, and 9 ampere breaks other terminal joined together, connected to positive battery clamp cable. The AC power of 240 volt plugged in the socket, however it has not been switched on yet. The battery clamps connected a car bulb with 21 watt. Switch the AC power on, then switch the DC switch on. The meter showed the output of DC 14.8 volt and 1.82 amperes with the bulb lightened. No need to adjust here anymore for the voltage adjustment, although the output of 14.8 volt is a bit of high for a car bulb. It is good for charging a car's battery. Turned off this switch. Changing that bulb to a car battery now. The meter is indicating 12.5 volt, which is the battery's voltage. This is proved by no current from the meter's indication. Turn the switch on, now the meter is indicating. Charging voltage is 14.1 volt, current is 4.8 amperes, and decreasing continuously. Charging current goes down to 3.2 amperes now and still decreasing. A cooling fan is working very well. This car battery charger is working very well. Now you've known how to use a low voltage transformer such as 8.7 volt to make a car battery charger of 12 volt. Just add a DC to DC boost converter after rectifier. It is simple. Thank you for watching. Please like, share, comment, and subscribe if you have enjoyed the video. Your encouragement is my motivation.